Here is a Klon KTR. It does not work, according to the customer. Can I fix it? Guess what? I fixed it. Now, for the long video on explaining how and why. What is up, everyone? Today I have my buddy Mike's KTR, and this KTR is not healthy. It looks like whoever owned it previously, or somewhere along the lines, there was an issue, a power supply likely, went into this thing, and basically, as you can see on my scope, it works sometimes. It works in bypass. We have the always on buffer and true bypass. And they look good, but as soon as you engage the circuit, something funky's going on, and I have all the controls at noon. So I'm not very good at this. I'm trying to learn using this example. It does look like someone changed the chips here, the TL072s. They did not change the charge pump. And next to me, I have my Klon circuit board. So I'm going to use this sort of as reference and kind of walk through what I'm observing and what the next steps are. I proactively went to Mauser and bought here's the charge pump chip. Here is the op amps, so I can replace those if I think that those are busted again. Oop. And then here is the Zener diode, the protection diode, that is in this thing. I won't do it right now, but underneath it does look like it's been replaced. So yeah, I'm not sure I trust that. So kind of what I'm going to do right now with you guys, and hopefully the screen is somewhat clear. Gonna kind of look through and probe around. So I have my probe. I'm sending in I believe it's a 500 hertz signal wave using my signal generator over here in the corner. Sorry for the mess. So I'm just gonna kind of probe around. Right now, this probe is set for DC, and I have the pedal engaged. So now I'm gonna use the measurement tool on my oscilloscope, and I'll read them out loud, so in case you can't read it. Actually, let me see if I can. I can't really. Yeah, there we go. But then you can't see what I'm probing. Anyway, I'll just read them out loud, just in case you can't see. All right, so I have a drawing right here that I'm going to follow that kind of made up. On the left is the TL072. So really what I'm going to look for is VCC and the ground and measure those, as well as on the charge pump. Here's the charge pump. We have 9 volts. There is some diodes, so I need to measure after the diodes here to get the charge pump voltage out, which should be around 16.2. V out down here should be negative 8.6. Let's start probing around. See what we got. So first thing I'm going to do is just see what kind of the voltages we get from TL072 with the pedal engaged. Again, it doesn't make too big of a difference. This is bypass and with the buffer. So I know one of the chips is working because it's going through the buffer. But with the pedal engaged, things get a little scary. All right, so now I'm going to probe VCC, which is pin 8. And that measures 8.4 median. So I'm basically reading the mean. This other chip, 9.37 volts mean. I think these are just ground, so they won't measure anything. But, oh, no, that's 7.37 volts. And then this one, for ground, that might be ground. It's not really measuring anything. So if it was ground, let's try over here. Yeah, I get about the same result. So I don't think that there's anything there. Let's go ahead and look at the charge pump. over here. So I'm going to first do pin 8. And that looks like a solid 9.37 volts. These aren't connected, but let's just see what they are. So pin 7, 8.7. Pin 6, 8.2. Pin 4, 5, 8.38. So already I'm sort of, and that's a positive, by the way, when I think it should be negative. So I think that this charge pump is the problem. Just a quick sort of off the cuff. This is positive 8.4. Feels like all, and that ground is just ground. 9.32 on pin 2. 9.37 on pin 1. So already I'm seeing some issues. And remember how I said on the other side of the op amps, we should be getting roughly, or sorry, not op amps, on the other side of the diodes, we should be getting 16-ish, and I'm only getting 8. So something's not right. And for reference, I'm not even going to go in and try to find the signal or trace the signal. All right, so just for reference, I have this pedal engaged. It doesn't have a signal in or out, but the ground is connected to this ground, which is connected to that ground. So I don't need to ground this probe. So let's do pin 1, which is just a boost. There we get 9.28 volts. Pin 2, 4 volts. Pin 3 is ground, so that's not going to do anything. All right. And already I can tell a difference. So cap negative is, guess what? Negative voltage. I did not see negative voltage on the other one. Pin 8. If I'm on pin 8, 9.3. This OSC, the oscillation, I think that means, is 4. That one's 4. And we get a healthy negative 8. Now, for reference, that's a negative 8. This one over here says positive 8. Something's weird. Again, here's some diodes. Let's see what happens on the other side of the diodes. 8 and 8. Let's see what happens on this side of these diodes. That one's 13. And this one's 16. So voltage coming into this chip over here is good. Voltage coming out, bad. I'm going to go ahead and swap that out. Not using this, but using this. No, yes, using this. This is the exact part number as used on the real deal. So I'm going to fire up my soldering iron and get a solder wick going. Maybe even get my vacuum pump and look into replacing this dang thing. First thing to do, always shut down your equipment before you plug something in, because remember, the center is ground on these things, so if you pull it out and touch anything that's around here, that outer ring is 9 volts. The center is ground, so the 9 volts will actually arc and make issues. Just going to shut this stuff down. This oscilloscope is my pride and joy, so I want to make sure that that's good. I'm actually going to even go ahead and unplug from the power supply, so you're going to see the green light turn off, because I don't want any chance that this thing is going to get fried. Since this thing is unplugged, you can see that someone applied a bunch of heat to this Zener diode, this protection diode, which did its job, I guess. No, actually it didn't, because it fried everything. That's the chip we're going to replace. All right, Got some heat applied to the soldering iron. It's all tinned and nice. I'm gonna get in here. I don't know how good this will be. I have my toothpicks ready to go. But I have my solder wick. I have a fancy, I should get it warmed up. I have a fancy desoldering device, but it needs to start warming up. So I'll plug that in. All right, that's plugged in. It's warming up. See what happens there. Over here, let's see what happens here. The idea is to just sort of let the wick do its thing. You do need to apply a little bit of heat to counter, because the copper braid acts like a heat sink. And when they solder these things, especially the surface mount, they don't need a lot of solder. They apply just the right amount, typically. I don't know if that did anything. Well, it looks like there's some solder on here, but I don't know if that was just from the tinning or what. Let's see. Some heat. Is it extracting anything? I don't think so. Maybe. I'm a little shy on using it, but I have a heat gun that is not like so much a heat gun, but it's a blower of sorts. It's supposed to be for this type of repair. Maybe I'll get it out and try it too. But basically you blow the hot air, try to get it on just that area, and then you lift the pads up, because in theory it should kind of melt the solder everywhere. But I'm a little uncomfortable with that. And plus on camera, I'm trying to do my best to do the things the right way. Alright, got my fancy solder sucker. I just press this button and it will suck up solder. So I'm going to try to heat the area first, then press the button. I have no idea if that's doing anything. And a lot of times with this compliant solder, it actually takes a lot of extra heat, and that doesn't look like it's doing anything. And because it is compliant solder, some things you can do as a trick is apply new solder to it, which is lower temperature, and then you lower the temperature of what you're trying to do. So I'm just going to go ahead and do that now. It's going to apply a bunch of lower temperature solder. This is Quad Eutectic Premium. I love this stuff, by the way. Audio grade, whatever. But I like how it's low temp. And you can mix it sort of with this other stuff. And let's try the wick again. Wherever it went. Let's give it a try. Oop, I'm going to actually take the solder off my tip here. And you can see that I bridged a connection. I absolutely would not turn this on at this point, but let's use the solder wick to clean up the mess that I made. But it's a intentional mess, just to lower the temperature of the area that I'm working on. And I've actually seen online, I don't know how good it is, but people will flow a whole ton of solder in here, take their soldering iron and sort of not so much bridge, but just like extend it across all the leads. Alright, as you can tell, that's sort of cleaned up. This is incredibly difficult with a camera in front of me. Where normally I can be in all sorts of gymnastics positions to do this sort of work. Another thing you can do is sort of slide this. Again, my goal here is just to remove the solder here as much as I can. I have this lower temperature. You can see that's sucking up real nice. Gonna clean that up as best as I can. Going back and forth. Looks like this is a better technique. That discoloration is just the resin from the solder, not distorting anything from heat. You want to be also very careful not to lift any of these pads. So as I kind of go back and forth, I'm being extra careful and paying attention to the resistance and any sort of damage that I might be doing. All right, next thing. I guess I'm just going to try to lay this down. Lift up these pads. Not the pads, but the legs. Do not want to lift up the pads. All right, I'm going to do this off camera because I don't want to create an issue. All right, so 3 seconds after I let off the camera, I started to lift up one of the legs and the whole chip popped off. So I'm just going to double check and make sure I didn't lift any pads in the process. But here is what I think is a bad chip. I'm just going to go ahead and, with our desoldering braid, clean this up a little bit. Again, be very careful that you're not catching a pad and lifting it. But I'm just trying to clean up what we have here. So I want the new chip to lie down nice and flat. So I'm just going to go with the direction of the pad. You can see it all get cleaned up. Hopefully. Can do that this way. Oops. Okay. There we go. That one's all cleaned up. And as you can tell from the previous repair person, I don't think that they did that. I don't think they cleaned the pads after they or when they were in the process of changing out those chips, because it's not really lying flat. You can see that they're sort of, the legs are raised. It's not really in alignment. This is much better. So at this point, I'm gonna take my flux wash, go to the sink, and spray this flux wash right here. Clean up those pads. All right, after that flux wash, pretty clean pads here. I'm sort of debating, do I go ahead and replace the other chips and fix them? Make them real pretty much new in this thing? I think I will. But let's just see first. But also there's, if it ain't broke, don't fix it sort of thing. We're going to see after I do this and how much effort. Because I also don't want to, if that's been resoldered, tinkering with these pads can be a little nerve-wracking. So I might just leave it, actually. As long as this thing works, I think Mike will be a happy customer. All right, I don't want to touch anything, but I use my little toothpick tool. Dentist tool. No. And I got this thing perfectly aligned. Now, I'm going to do my best to tack one of the leads in place without moving anything. Ah, I moved. This is why people go crazy. And I don't have any solder paste. I know. That's going to be the first comment. Why don't you use solder paste? I don't have any, bro. Alright, you know what I'll do? Let's get one pad. Heat it up. Let's see if I can move this thing. And then get it in place. How frustrated are you guys right now watching this? I would be. So I might edit. Okay. I think that's good. And go ahead and do the opposite corner. Yes. Okay. It's gonna go up. Try not to do too much. All right, time for the microscope inspection and a flux wash. All right, so moment of truth. Got everything plugged in, plugged up. I hear my dogs barking. I hear a little bit of clock noise, which is interesting, like a high-pitched whine. And let's turn it on, see what happens to the waveform. Whoa, okay. Think. All right, that's okay. Turn this on again. I think we have a pedal that's working. Super cool. I guess next thing I do is plug it in. It's no, I think that's the level, if I were to guess. Plug it in and play some real guitar through it. Okay, remember how I said I was hearing an audible whine? Well, here is how the circuit is supposed to look. And that frequency, you see it at 25 kilohertz. That's with the boost enabled. Well, when I plugged in the guitar and started playing, I heard some whining, and sure enough, the frequency is at 7.15 kilohertz. And I have the boost on. I made sure that contacts was correct. The problem is, I realized that this particular chip, which I thought I was ordering a 1-for-1 what was already there, this chip does not have the boost feature enabled like the Max 1044 ESA, blah, blah, blah. So I couldn't find the ICL7660S, which has the boost enabled. There seems to be a shortage of them right now. But a perfectly acceptable alternative is this. So I'm going to go ahead and replace this chip one more time with this one, and we should be getting a boosted frequency the same as this one over here. Stand by. All right, I reworked with the new chip, and let's check out the frequency. I mean, I can already tell that we're looking good because I got the effect on, and when I change the knobs, we got some cool things going on. So let's check out the frequency. I don't hear any audible whining, so this capacitor is in charge of that stuff. And we have 40 kilohertz. So that's even higher than, let's see, pin 2 than the original style chip. So, do I dare say that this is an upgrade? Because it really shifts that frequency out of the audible range. I mean, maybe. But it's definitely going to help. So, next up is a sound test.